Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. Today's video is of class 12 mathematics chapter 2 inverse trigonometric functions part 2. So make sure that you have watched part 1. Today we are going to study properties of inverse trigonometric functions. We have already learnt that sine inverse is a function from the domain minus pi by 2 to pi by 2. From the domain minus 1 to 1 to the range minus pi by 2 to pi by 2. It is defined as y is equal to sine inverse x if and only if x is equal to sine y. That is, sine inverse is a function from the domain minus 1 closed interval minus 1 1 to the range minus pi by 2 to pi by 2, defined as y is equal to sine inverse if and only if x is equal to sine y. So here our properties of inverse trigonometric functions are sine inverse of sine x is equal to x, x belongs to minus pi by 2 to pi by 2. See here, what is the closed interval minus pi by 2 to pi by 2? We know that it is the domain of the sine function, right? And the range of sine inverse function. So here it is enough to prove first one. Similarly, we can prove others. So first let us prove first one, sine inverse of sine x is equal to x. So for that, let us take let y is equal to sine x. Okay. And we have sine function. The sine function is a inverse function, right? It is an inverse function in the domain minus pi by 2 to pi by 2, range minus 1 to 1, right? Therefore, here we can write x is equal to sine inverse y, right? It can be written as x is equal to sine inverse y. Why? Since this function, sine function, is an inverse function, therefore write x is equal to sine inverse y. That implies x is equal to sine inverse of y is nothing but sine x. So sine inverse of sine x. So here we have got x is equal to sine inverse of sine x. That is, here what is x? It is nothing but element of domain of the sine function, right? That is, x belongs to closed interval minus pi by 2 to pi by 2. Okay, closed interval minus pi by 2 to pi by 2 is the domain of the sine function and range of the sine inverse function. So here x is nothing but it is the domain, okay, element of domain. Y is nothing but it is the range of element of range. Okay, so here we have got x is equal to sine inverse y. Since y sine x is a inverse function, that implies x is equal to sine inverse of y is nothing but sine x. So sine inverse of sine x. So we have got sine inverse of sine x is equal to x. Here x belongs to closed interval minus pi by 2 to pi by 2. Similarly, we can prove others. Evaluate sine inverse of sine 4 pi by 5. So here we have to find the value of sine inverse of sine 4 pi by 5. We know that sine inverse of sine x is x itself, right? Sine inverse of sine x is equal to x. So that x belongs to, x should be in minus pi by 2 to pi by 2, right? If x belongs to the interval minus pi by 2 to pi by 2, then it satisfies this property, okay? Sine inverse of sine x is equal to x. So for that, first of all, let us write the principal value branch of the sine inverse function. So we know that the principal value branch of sine inverse function is closed interval minus pi by 2 to pi by 2. Okay. So next thing we have to do is, we have to check whether this belongs in this interval or not. See, how to check it? See here, we know that 4 pi by 5, right? 4 by 5 is nothing but 0.8. 5 8s are 40, right? Okay. And here, see, what is our interval? Minus pi by 2 to pi by 2. That is minus 1 by 2. See, minus 1 by 2 means minus 0.5 to 0.5. Right? Minus 1 by 2 to 1 by 2. Okay. So here, minus 0.5 to 0.5. So here it is 0.8. Now, see, it is clear that this 0.8 does not belong in this interval, right? Because 0.8 is greater than 0.5. Okay, therefore here this 0.8 does not belong to this interval. Okay, therefore here we can write 4 pi by 5 does not belong to interval minus pi by 2 to pi by 2. Okay, then how to find the value of sine inverse of sine 4 pi by 5? See, if this 4 pi by 5 does not belong to in this interval, we cannot say sine inverse of sine 4 pi by 5 is a 4 pi by 5, right? So here, another way we can write, see, 4 pi by 5 can be written as pi minus pi by 5, isn't it? See, what is pi minus pi by 5? 5 pi minus pi, that is 4 pi by 5. So, 4 pi by 5 can be written as pi minus pi by 5. So, here sine 4 pi by 5 is equal to, that is sine 4 pi by 5 is equal to sine pi minus pi by 5. What is sine pi minus theta? See, in our trigonometric functions, we have already learned all these properties of trigonometric functions. Sine pi minus theta is nothing but sine theta, because it lies in second quadrant. In second quadrant, sine function is positive, right? So, sine pi minus theta is equal to sine theta. See, if you have any doubt in these properties, you go to my video of trigonometric functions. There I mentioned the trick or trick to memorize these all properties. Okay. So, sine pi minus theta is equal to sine theta. Therefore, here we can write sine pi minus pi by 5 is sine pi by 5. Okay. So, here sine inverse of sine 4 pi by 5 is equal to, see here, sine inverse of sine pi by 5, right? Sine inverse of, we can write sine inverse of sine 4 pi by 5 is equal to sine inverse of sine pi by 5. So here, see, now we have to check, is pi by 5 belong to this interval, that is minus pi by 2 to pi by 2. Let us take 1 by 5, right? See, 1 by 5, that is nothing but 0.2, right? So our interval is closed interval minus 0.5 to 0.5, right? So exactly, see, this 0.2 belongs to this interval, right? That means pi by 5 belongs to the interval minus pi by 2 to pi by 2. Okay? Pi by 5 belongs to minus pi by 2 to pi by 2. Now here, according to the properties of inverse trigonometric functions, we can write sine inverse of sine pi by 5 is equal to pi by 5. Why? Because pi by 5 belongs to minus pi by 2 to pi by 2. Tan inverse of tan 3 pi by 4. Okay. Find the value of tan inverse of tan 3 pi by 4. So here we have tan inverse of tan x is equal to x when only when x belongs to interval minus pi by 2 to pi by 2. Here not closed interval, open interval. Okay, minus pi by 2 to pi by 2. So here we have to find the value of tan inverse of tan 3 pi by 4. We have to check whether this 3 pi by 4 belong this interval minus pi by 2 to pi by 2 or not. Okay, so for that, first of all, let us write the principal value branch of tan inverse function, that is range of the tan inverse function. That is nothing but principal value of tan inverse function is, sorry, not closed interval, open interval minus pi by 2 to pi by 2. Okay, why it is not closed interval? Closed interval means pi by 2 is included, right? Here pi by 2 should not be included. Why? Because we know that tan pi by 2 is not defined. So pi by 2 should not be included in this range. Okay, so here we write open interval minus pi by 2 to pi by 2. And let us check whether this 3 pi by 4 belong this interval or not. See here, 3 pi by 4 See 3 pi by 4. 3 by 4. What is 3 by 4? 3 by 4 is nothing but 0 point something 7 something, right? Okay, 0.7. See our interval is nothing but minus 0.5 to 0.5. Okay, here also 0.5, minus 0.5, 0.5 not included in this interval, and here also our value is 0.7. It is greater than 0.5. Okay, obviously it does not belong to this interval, right? So here we can write 3 pi by 4 does not belong to the interval minus pi by 2 to pi by 2. Okay. Therefore, here we cannot write directly tan inverse of tan 3 pi by 4 is equal to 3 pi by 4. 3 pi by 4 should be in, if 3 pi by 4 in this interval, then we can write it is equal to 3 pi by 4. So, this 3 pi by 4 can be written as pi minus pi by 4, isn't it? 3 pi by 4 is equal to pi minus pi by 4, right? That is, see, 4 pi minus pi, 3 pi by 4. Therefore, sine 3 pi by 4 is equal to, not sine, tan, right? Tan 3 pi by 4 is equal to tan pi minus pi by 4. Okay, now what is tan pi minus theta? Pi minus theta. Pi minus means in second quadrant, it lies in second quadrant. In second quadrant, tan is negative, right? So, tan pi minus theta, that is equal to minus tan theta, right? Minus tan theta. So here that is tan minus tan pi by 4. Or we can write, we know that tan of minus theta is equal to minus tan theta. Tan of minus theta, tan minus theta is equal to minus tan theta. So we can write minus tan theta is equal to tan of minus theta. So this one can be written as tan of minus pi by 4. Okay, tan minus tan pi by 4 is equal to tan of minus pi by 4, isn't it? So this can be written as tan of minus pi by 4, right? And now see here, let us check. Let us write tan inverse of tan minus pi by 4 is equal to tan. Okay, now let us check whether this minus pi by 4 belongs to this interval, minus pi by 2 to pi by 2. See, what is minus 1 by 4? Minus 1 by 4 is nothing but 0.25, right? So minus 0.25, minus 0.25. Does this one belong to this interval? See, minus 0.25. See here, it is minus 0.5, right? See, it is increasing, right? Left side minus value, left is going minus, right side, right? Right side, it increasing the value, okay? So here, minus 0.2 will be somewhere here, right? Therefore, it belongs to this interval, isn't it? Minus 0.5 belongs to this interval. Therefore, here we can write tan inverse of tan is equal to minus pi by 4, since minus pi by 4 belongs to the interval minus pi by 2 to pi by 2, isn't it? Minus pi by 4 belongs to the interval minus pi by 2 to pi by 2. Therefore, tan inverse of tan minus pi by 4 is equal to minus pi by 4. So, its value is nothing but minus pi by 4. Sine inverse of sine 160 degree. Sine inverse of sine 160 degree. So, first of all, let us write the principal value branch of sine inverse function, that is closed interval minus pi by 2 to pi by 2. That is the range of the sine inverse function. So, here we have to find sine inverse of sine 160 degree. For that, let us check whether 160 degree belongs to this interval. See how to write in degree. We know that it is in radian. So, degree is nothing but it is equal to minus 90 degree to 90 degree, right? Pi by 2 is nothing but 90 degree. Okay, so here does this interval, that is, does this angle 160 degree belongs to this interval 90 degree to 90 degree, minus 90 to 90 degree? No, right? So, it does not belongs to 160 degree, does not belong to the interval minus closed interval minus 90 degree to 90 degree, right? Because 160 degrees, it is greater than, always greater than 90 degree. Okay, now, so how it can be written? 160 degree. 160 degree can be written as 180 degree minus 20 degree. Okay, so it should be a standard angle 180 degree minus 20 degree. 160 degree is equal to 180 degree minus 20 degree. So this one, let us write sine inverse of sine 160 degree is equal to sine inverse of sine 160 degree can be written as 180 degree minus 20 degree, right? That is sine pi minus 180 degree in radian, we can written it as pi minus theta, pi minus 20, right? Sine 180 degree minus 20 degree is nothing but sine pi minus 120 degree, right? That is sine pi minus theta. We know that sine pi minus theta is a sine theta itself, right? Therefore, here it can be written as sine inverse of sine 20 degree, right? Since sine pi minus theta is equal to sine theta. Okay, so sine inverse of sine 180 degree minus 20 degree, 180 degree is nothing but pi, okay, in radian pi itself. So 180 degree minus 20 degree, that is equal to sine inverse of sine 20 degree, that is equal to, see, first of all, writing sine 20 degree, whether check whether this 20 degree belongs to this interval. Yes, obviously it belongs to this interval. 20 degree is nothing but, see, 20 degree is less than 90 degree, right? So 20 degree, it belongs to the interval minus 90 degree to 90 degree. Therefore, sine inverse of sine 20 degree is 20 degree, since 20 degree belongs to the interval minus 90 degree to 90 degree. Therefore, the value of sine inverse of sine 160 degree is equal to 20 degree. Write tan inverse of square root of 1 minus cos x divided by 1 plus cos x. Here it is given x less than pi in the simplest form. We have to write it in the simplest form. Okay. So for that, see, here we have to apply trigonometric identities. Okay, once I already mentioned that all the trigonometric identities are very important. Okay, so here it is applicable in algebra, calculus, etc. So anytime you should be aware of these identities, trigonometric identities. So here let us see. Square root of 1 minus cos x divided by 1 plus cos x. So what is 1 minus cos x? How it can be written? See, 1 minus, we know that 1 minus cos 2x, it is nothing but 2 sine square x. Right? 1 minus cos 2x is equal to 2 sine square x. So what is 1 minus cos x? 1 minus cos x is equal to 2 sine square x by 2. Okay? Here, when it is 2x, it is x. When it is x, it is x by 2. It's half. Okay. So 1 minus cos x can be written as 2 sine square x by 2. And what is 1 plus cos x? Here also similarly 1 plus cos 2x is 2 cos square x. Okay. 1 plus cos 2x is 2 cos square x. So 1 plus cos x is nothing but 2 cos square x by 2. So this can be written as tan inverse of square root of 2 sine square x by 2 divided by 2 cos square x by 2. That is equal to, see here, 2 cancelled, okay, square root of sine square x by 2 by cos square x by 2. That is, what is sine square by cos square? Tan square, right? So it can be written, that is equal to tan inverse of square root of tan x by 2, tan square, okay, sine square by cos square is nothing but tan square. So sine square x by 2 by cos square x by 2 is nothing but tan square x by 2. So when take its roots, so it will be tan inverse of tan x by 2. Okay, here we have already studied that tan inverse of tan x is equal to x when only when x belongs to the open interval minus pi by 2 to pi by 2. Right? That is the range, that is the principal value branch of the tan inverse function. So here also we have to check, then only we can write. Okay, we have to check whether this x by 2 belongs to the interval minus pi by 2 to pi by 2. See here, for that it is given x less than pi. X less than pi implies x by 2 less than pi by 2, right? So this x by 2 is the value less than pi by 2. So therefore we can write x by 2 belongs to the interval minus pi by 2 to pi by 2. Right? Therefore it belongs to minus pi by 2 to pi by 2. Therefore it is equal to x by 2. Okay? Tan inverse of tan x by 2 is nothing but x by 2. Since x by 2 belongs to the interval, open interval minus pi by 2 to pi by 2. That is the principal value branch of the tan inverse function. So before applying this property, you have to check whether this value, okay, whether this value belongs to the interval. Okay, interval, that is the principal value branch interval. Okay. Write the function tan inverse of root of 1 plus x square minus 1 divided by x not equal to 0 in the simplest form. So here also we have to write this function in the simplest form. See here our function is tan inverse of. So we have to do is, we have to make this portion tan of. Okay, so that we will be able to apply the inverse trigonometric properties of the inverse trigonometric functions. So here let us write what is the given function. Tan inverse of root of 1 plus x square minus 1 divided by x, that is equal to, say here, let us put x is equal to tan theta. Okay, put x is equal to tan theta, so that we will get 1 plus tan square theta. We know that identity 1 plus tan square theta is c square theta. Okay, so x is equal to, put x is equal to tan theta. That implies theta is equal to tan inverse x. Okay, so here let us substitute x is equal to tan theta, so that it will become tan inverse of square root of 1 plus tan square theta minus 1 divided by tan theta. Okay, that is equal to tan inverse of, what is 1 plus tan square theta? That is the basic identity of the trigonometric identities. 1 plus tan square theta is nothing but sec square theta. Okay, so sec square root of sec square theta minus 1 divided by tan theta. Okay, square root of sec square theta is nothing but sec theta itself, right? That is tan inverse of sec theta minus 1 divided by tan theta. Okay. Now here sec theta can be written as 1 by cos theta and tan theta can be written as sin theta by cos theta. So that is how the cos theta will be cancelled, right? So next step, it will become tan inverse of sec theta is 1 by cos theta minus 1 divided by sin theta by cos theta. Okay, taking the LCM in numerator, we will get 1 minus cos theta divided by cos theta. And here also numerator of numerator, that is also cos theta. This cos theta will be cancelled, right? That is denominator of numerator and denominator of denominator cos theta is cancelled. Okay. So after cancelling, so tan inverse of 1 minus cos theta divided by sin theta. 1 minus cos theta divided by sin theta. See, next, see what is 1 minus cos theta? The previous problems we have already applied. 1 minus cos theta is nothing but 2 sin square theta by 2, right? Tan inverse of 2 sin square theta by 2 divided by, see if we write sin theta itself, it will not be cancelled. Okay, we will not get the answer, right? So here also let us apply the identity. We know that sin 2 theta is equal to sin 2 theta is equal to 2 sin theta cos theta, right? So what is sin theta? We have sin theta. Okay, only sin theta. So sin theta is equal to 2 sin theta by 2 cos theta by 2. Where it is 2 theta, it is half of 2 theta, theta. And here it is theta, we have only theta, therefore half of theta, that is theta by 2. Okay. So sin theta is equal to 2 sin theta by 2 cos theta by 2. Let us apply it. 2 sin theta by 2 cos theta by 2. Okay. Now here sin 2 cancelled. Okay. Sin theta by 2 sin theta by 2 cancelled. So remaining tan inverse of sin theta by 2 divided by cos theta by 2, that is tan inverse of tan theta by 2. Okay, we know that is ratio of sin and cos. Sin theta by 2 by cos theta by 2 is nothing but tan theta by 2. So tan inverse of tan theta by 2, that is equal to theta by 2. And here what is theta? Theta is nothing but tan inverse of x. Okay. So tan inverse x divided by 2. Okay. That is equal to tan inverse x divided by 2. Show that tan inverse of cos x divided by 1 minus sin x is equal to pi by 4 plus x by 2. So we have to simplify this one. Okay. That is, first of all, we have to make this portion as tan of, so that we will be able to apply the properties of inverse trigonometry functions, right? So let us write the function, given function tan inverse of cos x divided by 1 minus sin x. Okay. So we have to make this portion tan of something. Okay. So here cos x, see how it can be written. Cos x, we know that cos 2x is equal to cos square x minus sin square x, isn't it? So cos x is nothing but cos square x by 2 minus sin square x by 2. Okay, when it is 2x, here half of 2x, that is x, and when it is x, half of x by 2. Okay, so cos x can be written as cos square x by 2 minus sin square x by 2. So here we are going to simplify only this portion. Okay, so write tan inverse of cos x can be written as cos square x by 2 minus sin square x by 2 divided by, see here there is no identity 1 minus cos x, okay, 1 minus sin x. So but here we can write, see it is in the form x by 2, right? So we can write it as, we can write 1 as sin square x by 2 plus cos square x by 2, right? Why? Because we know that sin square x plus cos square x is equal to 1. Sin square y plus cos square y is equal to 1. Okay, anything, any angle, in any angle, sin square pi by 4 plus cos square pi by 4 is equal to 1. So here also we can write 1 as sin square x by 2 plus cos square x by 2. Okay, sin square x by 2 plus cos square x by 2 is 1 minus sin x. How it can be written? Sin x. We know that sin 2x is 2 sin x cos x, right? We have only sin x, so sin x is nothing but 2 sin x by 2 cos x by 2. Write it here, 2 sin x by 2 cos x by 2. That is equal to, okay. Now here, look at the numerator, cos square x by 2 minus sin square x by 2. It is of the form a square minus b square, right? So what is a square minus b square? A plus b into a minus b. And look at the denominator. See, denominator is of the form a square plus b square minus 2ab. What is a square plus b square minus 2ab? A minus b whole square. So now let us write it as tan inverse of a square minus b square, that is cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. Understood? That is a square minus b square is nothing but a minus b into a plus b. A minus b into a plus b. Okay? Divided by, now it is of the form a square plus b square minus 2ab, right? So a square plus b square minus 2ab. That is nothing but a minus b whole square. So here let us take cos x by 2, cos x by 2 as a, because we have numerator cos x by 2 minus sin x by 2. So cos x by 2 minus sin x by 2 whole square, right? So this can be written as cos x by 2 minus sin x by 2 whole square. And see here, look at this expression here, numerator cos x by 2 minus sin x by 2 and denominator 1 cos x by 2 minus sin x by 2 will be cancelled, right? So it will become tan inverse of, it is cancelled, okay, it is cancelled, cos x by 2 plus sin x by 2 divided by, here remaining, cos x by 2 minus sin x by 2, okay. And next, see what is the next step. Here let us divide numerator and denominator by cos x by 2, so that we will get tan x by 2, right? See, because see here, divide this numerator and denominator by cos x by 2. Tan inverse of, no change in tan inverse, okay, we are simplifying only inside part, okay, cos x by 2, divide, let's divide numerator and denominator by cos x by 2, okay. So it will become 1, cos x by 2 by cos x by 2, 1, plus sin x by 2 by cos x by 2, tan x by 2, divided by, here also cos x by 2 by cos x by 2, 1, minus tan x by 2, okay. See here, 1 plus tan x by 2 divided by 1 minus tan x by 2. And next, here we know that tan, what is tan of x plus y? Tan x plus y. Tan x plus y is nothing but tan x plus tan y divided by 1 minus tan x tan y. Okay. Now here, if x is equal to pi by 4, we know that tan pi by 4 is 1. Okay. So we can write it as, see, we will apply this identity, this formula, tan inverse of 1 can be written as tan pi by 4, okay, because we know that tan pi by 4 is equal to 1. So tan pi by 4 plus tan x by 2 divided by, here 1 itself, okay, write as it is. And next, here we will multiply 1, okay, we know that 1 into tan x by 2 is equal to 1 into tan x by 2. So that 1 can be written as tan pi by 4, okay, into tan x by 2, okay. It is same as this one, okay, that is, it is equal to this one. Tan pi by 4 is 1 plus tan x by 2 divided by 1 minus 1 into tan x by 2, that is tan x by 2. Okay, now it is of the form, this one formula, right? So here we can apply this formula, that is nothing but tan inverse of, it is nothing but tan of pi by 4 plus x by 2. Okay. Now according to the properties of inverse trigonometric functions, tan inverse of tan pi by 4 plus x by 2 is equal to pi by 4 plus x by 2. Okay, hence it is proved.